For this centripetal force problem, I recommend you pause the video at the problem statement, work it out yourself, and then look and see how I do it.
As usual, we're going to draw a picture, and the picture is of a hydrogen atom. So we're going to have to enlarge it a lot. So here is hydrogen atom, proton in the middle. Is that what a proton looks like? Beats the heck out of me. Electron in orbit around the proton. Now, according to this, it says that this electron has a mass of 9.11 times 10 to the minus 31 kilograms. And the electron also is moving at a speed which is 2.2 times 10 to the 6 meters per second. That's its speed. Okay, good. And the distance from the proton out to the electron's orbit is a distance that says is 5 times 10 to the minus 11 meters. So we know all that stuff. That's a good start. So here is our diagram. So then what kind of physics principle can we use to work on this? Well, what the diagram tells us, is what the problem tells us really, is it says, what is it that is the force needed to keep this electron moving? So we need a force. So what kind of physics principle here is this? Centripetal force. That's a generic term for some kind of force, which is keeping something in circular orbit. And in this case, well, all cases really, centripetal force is mv squared over r. So we're asked for the centripetal force. That's what part A is. So now that's pretty good because the centripetal force is something we don't know. M is given, V is given, and R is given. So we're in fine shape. All we have to do now is put in the numbers and see how it works. F centripetal is M, which it says is 9.11 times 10 to the minus 31 kilograms, times V, which is 2.2 times 10 to the 6 meters per second. That has to be squared. Whoa, what square is that? Has to be squared. And divide that by R, 5 times 10 to the minus 11 meters. Great. We know all that stuff. So now the mathematics is pretty straightforward. All we have to do is calculate. It turns out to be 8.82 times 10 to the power minus 8 newtons. So there's our answer. That's how much force is needed to keep the electron in its orbit. Is that reasonable? Is it not reasonable? Who knows? Electrons are beyond our capability really to estimate well. But there is a B part. The B part says, that's A. The B part says, from a preceding problem, we could find the force of attraction gravitationally between the proton and the electron. So if that's the gravitational force of attraction between them from that earlier problem, what was it? It was 4.06 times 10 to the minus 47 newtons. That's how much gravitational attraction there is. Is that enough? Nowhere near. Look at all the differences in orders of magnitude. I mean, this is decimal point 47 zeros 4. Whoa, right. It's never going to make it. So then, what conclusion can you draw from this? Well, that is, it's not the gravitational force which keeps the electron in its orbit in the hydrogen atom. You didn't think that was true anyway. So that's the point of this problem. And